red, green, blue. I'm just putting that aside. The big thing with organic is that there's not clear distinctions for the grades. It's just a matter of getting how many right. Okay. I'm just going to pick a color and run with it. So, as requested, you guys want me to go over part... Oh, my hair feels like a messy. Okay. You guys have requested that I do one of them just to help get you guys going, and then I want you guys to try to do the second one by yourselves. Does that sound okay? This one is the harder of the two. I am sorry. But it does have the same principles because it has the same idea of you are thinking about identification tests. Okay? So... first bit here, when we're looking at this question, let's unpack it. It's really useful to annotate it so that way you guys know what you're trying to think about. So we've discovered that we're dealing with propan-1-ol, propanoic acid, and propenyl chloride. All of those tell me that with the prop, that these are 3 carbon chains. So when I'm thinking about this, if I'm mixing it with water, all of these should be soluble. Again, if I think about functional groups, when we were doing that list. Yes. So you look over here, the ones that tend not to be soluble are these guys over here. Not on the screen. Oh, good to know. There you go. Nope. 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 It helps if you plug in the HDMI cable. I'm so smart. Oh, because if you plug in the HDMI. There you go. Now you see. Okay. So, first bit of information is the number of carbons because that can help me with solubility. When it comes to things that are halocalkanes, alkanes, alkenes, and alkynes, these tend not to be soluble because they are nonpolar molecules, or if they are polar, it's only a very small section of it and it doesn't actually interact with water to make hydrogen bonds. So, that's the first thing to keep in mind. The ones that I'm seeing here are acid chlorides, carboxylic acids, and an alcohol, and they all are under 4 to 5 carbon lengths, so I would expect all of these to be soluble. So based on the functional group and on the carbon length, these should all be soluble. All right, so that's how we need to be unpacking the question and thinking about it. So number of carbons, we have 3. All these functional groups, we have an alcohol. We have a COOH, a carboxylic acid. We have an acid chloride, C double bond O, Cl. So all those factors would mean functional group and number of carbon, I should expect solubility. So that's the first thing. So all soluble. So what that means is when I am doing my comparison, solubility is not a way that I can distinguish them. All right. I know with alcohols, there's multiple ways I can test for it. When I look over here, it's using permanganate or dichromate. So there's my dichromate and that's my permanganate. That is actually not listed as one of my options, so I'm not going to be able to figure that out based off the test solutions that I've been given. Propanic acid, we are thinking about how do we test for carboxylic acid. So there's lots of different options here. Litmus paper, that's blue, universal indicator, metal, carbonate, or hydrogen carbonate. So those are all ways I can test for my acids. When I look at what they have given me, I see that they have given me blue litmus paper, so that is going to be the way that I'm going to test for my carboxylic acid. Are we good so far? And then last thing they say is that they've given me water, and I see that I have an acid chloride. So when I think about, okay, acid chlorides, they react violently with water. So that water will be a way for me to test for acid chlorides. So worthwhile unpacking the question. Keep in mind that you can't use things that they haven't stated. Sometimes when they give you these questions, they will not put any restrictions on what you can use as your identification solutions. Other times they will. So keep that in mind. This one they have restricted it, other ones they won't. I can actually show you guys some examples. Let's go to No Brain Too Small. Show you the collated questions. And we are doing identification tests now. Here we are. No, I don't want to find, I just want to zoom up. Thought that was going to magnify it. Go away. There we go. All right, so you see how on this one that was from 2021, it says use a chemical test to distinguish the following. So they tell you propanol chloride and amide, propanal and propan-2-ol, methyl ethanoate, and propene. So in this case, they've given you open range to pick your reagents. And the one that I've given you, I have not given you open range. Right? So both are possible. It is worthwhile to make sure you have them memorized so that way you can recall the information. Otherwise, you're going to struggle answering questions like this. Again, I would tackle it the exact same way. Annotate what you have function group wise so then you can think about what do I need to test for it. Are we okay? All right. So going back to this question, other things to keep in mind is that they want you to include equations where relevant. This is going to be a really important point because I often see that's where the excellence is if you remember your chemical equations. So just watch out for that one. Often an E point. So if I was thinking about how I would react it and I was thinking about it as like a step, the first thing I would do is I would add all my unknown solutions to water. Which is one of my reagents. If I added the only one that will be distinguishable from that is we're going to have two that are going to be soluble. And one will react violently. So it had like fumes and things like that. The one that reacts violently, that tells me that that must be the propanol chloride. And if I was to write that as a reaction, so this one is a chemical reaction because we're thinking about adding it to water. Propanol chloride would be CH3CH2 C double bond O Cl plus H2O. And then the reaction that is occurring is this, this Cl is getting replaced with an OH. So we're making a carboxylic acid. So that's that chemical reaction that's occurring.
Wait, what's replacing what?
So let me get another color. This Cl is being replaced, so the water is breaking up into H plus and OH. And the OH is substituting it out here. So the OH is getting attached to the organic compound, making propanolic acid, and then HCl is the other byproduct because this hydrogen is going to be attaching to that chloride. Mm-hmm. Cool. All right, next thing we got to figure out is what is happening with the second component. So both of these things are soluble. They are both soluble because they have the right functional groups that are going to be polar, that are going to be able to do hydrogen bonds, and they are short carbon chains. So now we got to figure out how do we distinguish these two. So if I was to take these two, my next step would be for the remaining two solutions, blue litmus paper, one of them will turn from blue to red. That one there is my carboxylic acid. So my carboxylic acid in this case is propanoic acid. This one also does have a reaction because you can state the dissociation to show that it's going to release a hydrogen ion. It's a reversible reaction because it's a weak acid. So what happens is it's going to lose that hydrogen ion and you're going to form a salt. So that's releasing the hydrogen ion. So this hydrogen ion here, just trying to grab another color, is going on there. So a proton donor, that is an acid. The one that remains blue is propanol. Sorry, propanol. Not an acid or a base. And that's how I figure out my 3 compounds. So basically you figure out this one by process of elimination. Which is a valid way to figure things out. Questions, concerns, or comments? Does that make sense? Caleb, you're giving me a funny look. What are you not sure about? No, you gave me a funny look like you didn't understand something. Huh? What's the question? Where are you stuck? Just gonna give me a thumbs up. Is anyone stuck? Or is that all okay? All right, just to kind of give you guys an idea of the points. So I have printed out the marking schedule. It is on Google Classroom. The achieved for 1 point is figuring out a chemical. So you have to identify one of them. So you identify, for example, the propanol chloride. Actually, did I have a number on there? No, I didn't. So that is an example of getting one of them. Or you note that the the propanoic acid. Or you identify the propanol. Propanol. So identification of one molecule isn't achieved. The other way to get the achieved is one chemical equation, either word or symbol. So this equation or this equation. So there's an A point for identification. And there's also an A point for equation. And the equation could be word or symbol.
So the one you did a symbol?
The one I did a symbol.
What would it look like for word?
So it was word you would write. Good question. Let me show you what it looks like. So I would write propanol chloride. Plus water makes propanic acid. Spell it right. Plus hydrochloric acid. I don't actually think it's easier to write the word equation. That's what it would be if you did a word. Doesn't need both. All right, keep going. All right, the merit point is devises the correct method with observations identifying all 3 substances. So you need to figure out all 3 of these things, what they are. You also need observations. So reacts violently, turning blue to red, remaining blue. These are all observations. For the merit requirement, though, you do not need to have any of those equations. And then for the excellence is having that with at least one equation or name or structure of the products. The other thing I was looking for the excellence is that you were specific and not just saying carboxylic acid, acid chloride, alcohol, but actually naming what the specific acid is. So propanic acid. So basically, excellence was making sure you had these equations in here. Okay. Not too bad, I hope, you guys are thinking. So that's the identification question. You have to have those tests memorized. You guys okay? No, where are you stuck? Where are you stuck? It's just like spec, but you just use the identification test instead. Julia's a little bit. All right. I'll start you on the next one. Okay. Next one here, I have given you guys a formula. So treat it like it's kind of like a spec question in a slightly different context. So they say unknown X has this molecular formula C3H6O3. When we look at the ratio between carbon and hydrogen, it is times 2. Is it times 2 plus 2? No. So that tells me that we have a double bond. Now they've given me a list of things. It says that it reacts with magnesium. So you need to look at your list here and try to find, it's probably not going to have magnesium, but it will have the word metal. And that'll give you a hint of what functional group is here. The next thing it says is that X is heated with acidified potassium dichromate and it changes color. So look at what potassium dichromate does and what are the potential functional groups that could do that. It says, but it does not react with Toland's agent. So this is the second product. So this is the first reaction, second reaction. So product. So be mindful, it's a secondary product. And then don't worry about this last bullet point. I will talk about that separately because we haven't done esters yet. Okay? Give it a go. Figure out what compound X is. Do you guys want this as one big video or would you rather have it in 2 parts? 2 parts? All right, so I'll stop the recording and then I'll start a new one.